Hi Trigoners! So today we are going to take notes on section 1.2, which is interval notation, and section 1.1 we're going to do some word problems today. So let's start with the interval notation. Let's just remind ourselves, when you see the U, that was a union, which could mean or everything, and this intersection symbol would be and or shared. So let's just do a quick example. If I have two sets A and B, would you please find a union B and find a intersection of B? So go ahead and pause the video and give it a try. Okay, let's check our work. So A union B, you're thinking, where do you, what elements are in A or B? So I listed all of the elements, but for intersection, I would say, what elements are in set A and in set B? Okay, so now let's go ahead and practice a little bit with interval notation. So I would like you to write as a single interval if possible. So the first thing we're going to do is think of a number line, and we have the numbers 2, 9, 13, and 15. So again, this is a number line, so make sure that the smaller numbers are to the left. So what I would like you to do now, I think it might help if we use different colors. So I'm going to choose red. And this says 2 to 13. There we go. And then I'm going to choose a different color. How about green? And I want the numbers from 9 to 15, and these are in parentheses. So for the first question, go ahead and tell me what would be interval notation if I want to do a union, and then for the second question, an intersection. Give it a try. Go ahead and pause the video and go ahead and write your answer down. Okay, let's check our answer. So for the first problem, it was a union. So I'm thinking, where do you see red or green? And I see red or green from 2 to 15, including the 2, not including the 15. But for the second part, I want to know, where do you see red and green? I only see red and green between the 9 and the 13. Not including the 9, yes, including the 13. So there's a difference between an intersection and a union. Okay, so let's go to the next part, and we're going to talk about inequalities. So the first question is, -3 less than 5. If this is a true statement, and you would say, sure. But here's what I want you to think about. What happens if I take this true statement and I multiply both sides of the inequality by -1? Is this still a true statement? And you would say, no, that's not true, right? What you would have to do is flip the arrow. Okay, so I want you to keep that in mind when I ask you the next question. So the next question is, solve x squared less than 0. So I want you to pause the video for a minute and think about, how would you solve that inequality? Okay, when you thought about it for a little bit, did you realize it's not really that easy to think of algebraically? And again, probably because there are many cases involved, with the example that we just did as far as flipping the arrow, etc. I think the best way to solve this would be to graph it. So we know that x squared, we could graph that, and now I want to know what x values have y values less than 0. Well, looking here, I don't see any, so that would be no solution. Okay, what if I changed the question and I said x squared greater than 0? Go ahead and pause the video and answer x squared greater than 0. Why don't we go ahead and do x squared less than or equal to 0 and x squared greater than or equal to 0? Go ahead and answer all of those questions. Pause the video and see if you can find the answer. Okay, so notice that if you look at the graph, this is a very much easier to see and visualize that x squared is greater than 0 everywhere except at 0, because there's a point at 0, 0. X squared is less than or equal to 0. Well, it's never less than, but it is equal to 0 at 0. And x squared is greater than or equal to 0 from negative infinity to positive infinity. So again, a graph was a great way to answer that question. Let's go ahead and try the next few questions. So what we're going to do is we are going to try and solve. Now, notice this does not have an equal sign. This has an inequality. So you have to be very careful of what we talked about earlier, that you have to flip your arrow if you multiply or divide by a negative. So go ahead and pause the video. And go ahead and try 5, 6, and 7. Okay, so for number 5, I distributed the 6, and then I added 12x to both sides of the inequality. Then we subtracted the 6 and divided by 4. Okay, so for the next one, notice it looks a little different. So this is a compound inequality, and notice that you're trying to solve for x. So there are a lot of ways you could do this, but it might be easiest if you just leave it the way it is and add 14. So now negative 12 plus 14 is 12. And the 14 cancels out, so we have 4x. And again, 2 plus 14, we have 16. So we're trying to isolate the x. So now we have to divide by 4. So again, we're going to divide by 4 3 times. And now we're left with our answer. So go ahead and pause the video and see if you can graph that solution on a number line and write the answer in interval notation. Okay, great job, everybody. Let's go ahead and try the last of these 3 problems here, number 7. So notice it says solve and graph the solution. So the problem is you have a denominator of 3. So think about something you can multiply each term by to eliminate the denominator. Okay, so let's go ahead and multiply by 3. So we're going to multiply each term by 3. And that looks better already. So go ahead and pause the video and solve for x. Okay, we add x to both sides of the inequality and subtract 1. When you divide by 2, yes, there's a negative, but it's on the other side of the inequality, not next to the x, so you do not flip the arrow. So we end up with x greater than or equal to negative 7/2. Okay, so we're going to try number 61. Again, notice that this is a compound inequality, so you're going to have to go ahead and isolate the x. Why don't you pause the video and try that one on your own. Let's check that first step. Did you multiply every term by 2/5? So on the left side of the inequality, notice we have the 5 and the 20 cancel out to give you, we have negative 8 because 4 times 2 is 8. Then we 2/5 and the 5/2 cancel out, and we end up with negative 2 over here on the right. Okay, so now we have to subtract 4. And lastly, we're going to divide by negative, and make sure when you do that you flip the arrow. So pause the video and write the answer in interval notation, please. Okay, so hopefully end up with 6, the interval from 6 to 12. Okay, so the next thing that we're going to do is we're going to talk about some word problems. Now these are called, I guess, job problems because you have one job to do. So I know in the past you might have done a distance equals rate times time. Well, we're going to say that one job equals rate times time. And I think this might make a little bit more sense if we do a couple examples. Notice I have some steps here that might help you with a word problem. Go ahead and read through those. Okay, so we're going to try the first problem. It says you're a barista at Starbucks and you can prepare 25 coffees per hour. So let's think about that. Isn't that a rate? And then it says, how many coffees did you make if you had an 8-hour shift with no break? So that must be a time. So we're looking for the number of coffees or the number of jobs. So go ahead and pause the video and see if you could decide how many coffees were made. All right, so for number 1 then, if you have 25 coffees per hour times 8 hours, notice that you made 200 coffees. Another way to look at it would be to look at the units. Notice that the hours cancel out and you're left off with 200 coffees. Okay, so number 2, it says you've been doing math problems for 5 hours, you've completed 100 problems. How many problems per hour can you complete? So you're looking for a rate. So go ahead and pause the video again and see if you can find how many problems per hour. Got it. So notice that rate times time equals job, and the job would be 100 problems. Or another way to think of it is you wanted problems per hour. So that would be 100 problems per 5 hours. So that's 20 problems per hour. Okay, go ahead and try number 3. Your printer prints 20 pages per minute. That's a rate. And you have printed 400 pages. How long has the printer been working? You're looking for a time. Go ahead and pause the video and find that time. So again, it also might help to look at the units here. 400 pages, and you have 20 pages per minute, so that's pages would cancel out if you divide by the 20, and notice you have 20 minutes. Okay, so now we're going to get into some of the tougher problems, and again, one job equals rate times time. Here we go. Two pumps are used to fill a storage tank at SeaWorld. Pump A can fill the tank by itself in 9 hours, and Pump B can fill the tank working alone in 6 hours. How long will it take both pumps working together to fill the tank? Well, the first thing you might want to do is make a table. We have rate, we have time, we have Pump A and Pump B. So go ahead and see if you can figure out what we would put in the table for the rate and the time for pumps A and B. Pause the video and fill in the table. Okay, so Pump A, notice it does 1/9 of the tank per hour. Since it takes 9 hours to fill the tank, it fills 1/9 of the tank in 1 hour. Pump B, 1/6 of the tank is filled in an hour. Another way to think about it is if 1 equals R times T, R equals 1 over T. So again, the rate is 1/9 tanks per hour for Pump A and 1/6 tanks per hour for Pump B. Notice we don't know how long it takes. So now we're going to say one job equals rate times time. So they're working together. So 1/9 T plus 1/6 T. So Pump A plus Pump B. Now, to solve this, I would probably multiply both sides of the equation by 18 so that we can eliminate the fractions. 18 divided by 5, you end up with 3.6 hours if they're working together. Okay, so let's go ahead and try the next problem. Go ahead and see if you could fill in the table for rate and time for Mrs. K and Gail. All right, so notice that the rate for Mrs. K is 1/3 because she can clean 1/3 of the cages per hour. And Gail, we don't know her rate. We don't know how many hours it would take her working alone, so we call that X. So now they are working together, so one job equals rate times time. So we have rate times time for Mrs. K and rate times time for Gail. So go ahead and pause the video and solve the equation. I would multiply by something that would make all of the, to eliminate all of the denominators. Okay, so did you multiply on both sides of the equation by 3x? If you do that, you end up with x equals 6. So that means that it takes 6 hours if they're working together. All right, so we have 2 examples left. Let's go ahead and try number 6. Pause the video, see if you can fill in the table for the rate and the time for Jeffrey and Jack. Okay, so notice it takes Jeffrey 3 hours, so his rate would be 1/3 because he has 1/3 of the room per hour. Where Jack, his rate is 2/5 because it's 1 over 5 halves, because 2.5 is 5 halves. 1 divided by 5 halves is 1 times 2/5. So we end up with 2/5. Okay, so notice that they are going to clean 2 rooms. So it's not one job, it's 2 jobs equals rate times time. And they're working together. So 2 equals 1/3 T plus 2/5 T. So again, I would go ahead and pause the video and multiply by something that will eliminate the fractions, or the denominators. Okay, so again, they had 2 jobs. So 1/3 T plus 2/5 T, I multiplied both sides of the equation by 15. So when I do that, I end up with 30 equals 5T plus 6T. If you solve for T, you get 2.73 hours of them working together. That was it for them working together to clean both rooms. So we're going to stop the video there, and you can work the last problem with Mrs. Corbett's in class. Have a great day.